I got a suggestion from one of my viewers to take a look inside this high voltage cover. If there's some arcing or corona going on with that high voltage rectifier, it could definitely be creating some interference on the CRT, so let's see what's inside here. Alright, let's see what we've got inside here. Conventional appearance of a high voltage coil and rectifier tube. I don't see anything obviously wrong. Oh, well, there's a dead spider down there. Might be causing some trouble. One thing I have noticed, though, is that this is a quite old rectifier. Quite likely the original. I say that because I see it has 8016 stamped on there, and it is a Motorola branded tube. So it could be as simple as this tube is kind of past its prime, so I'll try swapping it out with a known good one. Here's the old Motorola tube. The reason I say it was old is that 8016 was I believe the original tube designator for these tubes before they changed it to 1B3. And here is a nice new old stock RCA I'm going to put in this set. Make sure that socket area is clean too. Need to fiddle around with positioning this feedback coil just right, because this tube construction is slightly different, but generally somewheres around there between the cathode and plate is a pretty good guesstimate of where it should go. That's used to keep the oscillation going. Alright, yet another power-up test. No, the high voltage is working right. But all the interference is still there. So, certainly a fine idea, but unfortunately it didn't fix the problem. I'm working on going through the alignment procedure right now. I already did the 4.5 megahertz sound portion. That was pretty straightforward, although it was off quite a bit. And now I've just hooked up a sleep generator, and I'm looking at the overall response of the video IF, and that's kind of messed up. It's supposed to look like figure 3. The 22.9 megahertz marker isn't off too bad. That's right here. Let me show that on there. But 26, 22, 23, 24, 25, 26 actually isn't too bad either. It's supposed to be 50% down. But this stuff I don't think should be here, and this should be a bit flatter on the bottom there. Things a bit, so that's 23, 24, 25, 26. So yeah, 23 and 26. Not too bad. Actually, it's supposed to be 26.3, so it'd be more like over here. They're not down 50%, but they are at about the same level, so it's actually not that bad. But I will still go through and tweak it. Now, what I mean by not that bad is the overall shape isn't that bad, but I don't know about the actual gain. I mean, the coils may be off in terms of peaking them. So we need to go through and tweak these various coils at these various frequencies. I've been trying to follow the instructions as best I can, but the response is still odd, where I've got this hump over here and then a peak down here. Well, I discovered two things. One, that they actually do mention in the service info, is that the position of these components is critical, and in particular these two inductors, and I experimented and noticed that if I just take this one, well, actually if I just bring my hand near it, it changes things quite a bit, but if I actually move it, it can alter things quite a bit. So that's one reason why you often need to do an alignment, or you should if you can, if you do any work in the IF area, because just pushing a component around can really alter the IF response. Now, the other thing I discovered is these coils that I said I wasn't going to mess with, that I thought were traps. Well, when I adjust this one, not much of anything is happening. So I think this really is a trap, and whatever frequency it traps, may not have going through the set right now. I'm not really sure. It doesn't have much effect at all. However, this one has a pretty pronounced impact, so I think I'm going to have to be adjusting these whether I want to or not. So I'm turning it now, and as you can see, it's really altering that response quite extensively. A point where I can, I hope, make that peak go away. But even like this isn't quite so bad. It's kind of the usual double humped response. Now, in the diagram, they don't really show what's over here, so I don't know if this is acceptable or not. Typically, it would just be, it'd be very symmetrical, and you would have this on the other side, but so far I've not been able to knock this out. I did a bit more experimenting and determined that these are indeed traps. Low frequency trap, high frequency trap. I just hadn't rotated the core on this one enough to see the effect, so I didn't think it was having any. I think I can demonstrate that now pretty easily. So here's the response I currently have. Well, if I start cranking on this coil, this dropout here, this is that trap. See, the reason you want to have one, its low end and the high end, is to get a sharper cutoff on the sides to make it more like a plateau rather than a sloping hill, I guess you could say. Get that back over here. Now, I don't know exactly how these should be adjusted since I don't have any documentation, but I'll guess around about there is alright, which is about where it was when I started. And as for the other guy, if I tweak that one a bit, I can start getting something that looks like a more typical response curve with the double hump. And by the way, I can invert this, make it maybe look more like a response curve you're used to seeing. So in other words, these are the frequencies that are getting through. I had it upside down because that's the way they show it in the service info. So this marker is 20 megahertz, this is 30 megahertz, and basically each tick on the scope is another 1 megahertz. So 20 megahertz, 21, 22, 23, 24, 25. I can turn on markers for every megahertz, but that's just kind of overkill to see all this. You should just turn it off, and then, because I have these set up so that there are 10 divisions, and each division is 1 megahertz, I can tell pretty well that this is about 21.9, and this is 26.3, just like it's supposed to be. Alright, I think that's good enough. It's supposed to match figure 4 for this procedure, which is adjusting this first IF stage, which has a core on either side. So I will disconnect all this stuff like the 3-volt bias battery I had to hook up, and flip this thing down, reinstall the picture tube and all that, and let's see if this actually improved things any. Hmm. The sound is certainly great, and the picture looks pretty darn sharp, except for that speckly interference it's still on.
You want me to die alone? Oh, baby, no.
So I'm going to keep pursuing that suggestion that there's some high voltage arcing somewhere.
As each one comes in for his appointment, you just send him to the doctor as usual. I'll take care of them.
Can't smell the ozone, don't see any arcing, all the leads seem to be dressed just fine, but one thing I haven't done
Now, one of them is our killer.
is run the set with the high voltage cover off and see if there's something up inside that box. I'm not entirely sure you can properly though. I don't know, because there's a connection up here and this whole box is sort of grounded, so I don't know what effect removing that will have on the circuit inside, but I can certainly give it a try and see what happens. Oh, and something else I've been meaning to do that's really simple to do, so these tubes aren't too hot, is to swap out the two 25L6s I've got out here. So this is the tube that actually drives the high voltage inside there. Maybe there's something up with this tube, I don't know. Okay, I swapped the 25L6s and I took the cover off. Something else I want to do is that I measured the high voltage coming off of this and I got just about exactly 5,000 volts, and I think it should be a little higher than that. And the way you adjust that is you position this feedback coil. So I just slid it down a little bit. See if that makes any difference. Turn my scope off too so get rid of that background noise. If I still can't see any problem, I think I'll wait a couple hours. The sun will be down and maybe I can see better. Alright, now this I've seen before. That memory just came back to me, is that you run this without the shielding, you definitely get a lot of interference coming out of that. So maybe it's a matter of I need to install all those screws, because I only had about 3 out of the 10 in total are normally on there. I don't hear any corona hiss arcing sound. So I think that's okay in there. Well, I think I'm close. If I can just solve that interference problem, I can call this a successful restoration. Oh, and as far as this trimmer cap goes, the mystery one that was added on, it's disconnected right now. I wired up the bias on the mixer tube according to the stock schematic, so I think that was an experiment to try to improve or tweak something, but as long as the set works alright without it, I'm inclined to just leave it out of the circuit. Otherwise, I'll have to pick up a 3.3 microhenry inductor to try out, and it just occurred to me I placed an order at Mauser a few days ago and I completely forgot to order one of these. Oh well. Well, I'm still struggling to find the source of this interference on the screen. Along the way, I've found a few minor issues like the vertical size potentiometer, which should be 5 meg, was only measuring about 3.5 megs, so I replaced that, but that had no effect on this noise. Otherwise, the set is playing quite well. Great volume, pretty good sharp picture. The nature of this noise is kind of interesting, I think. One thing is that it seems to radiate kind of from the center of the CRT towards the edges, or at least they're sharply focused. It's more like dots in the middle, but as you get to the edge, they're almost like streamers going off to the sides. Also, it's affected by the fine tuning. So as you tune off the station, the interference kind of blends into the snow. It almost seems at some point like if I could just tune the station a little bit better, the interference would disappear, but you just can't quite get there. Like here's about the best I can possibly get. You tune off and it starts coming back until you lose the picture. Now one thing I've noticed is that if I put my ear by this high voltage box and listen real carefully, I can kind of hear a weird sort of metallic tinging, ringing kind of sound. I'm not quite sure it's coming from inside this box or something around it. Although it does seem to be loudest in this area. So a few things have occurred to me. One, well, it could be the picture tube itself, although I was using this in the VT71 restoration recently and it seemed to work fine, but doesn't mean it couldn't have developed a problem, so I can dig up another one of these and swap it out. Easy enough to do. And although I flip-flop these two 25L6s here and here, I can certainly replace that with another tube. Piece of cake. I've already swapped out the 1B3 rectifier inside here. It made no difference. But there is one more thing I can do. It's a little bit more drastic. I can replace the high voltage coil inside here. Now I've examined it closely with the set running, with the lights off and this cover removed, and there's no obvious arcing. And when I measure the high voltage, it's around 5,000 plus, which is about right for this set. They don't specify it on here, but the 6,000 volt filter cap, and so it wouldn't be higher than 6,000, I would think. And if you look up the recommended typical operating voltages for 7JP4, it's I think around 5.5 to 6,000 volts. So I think this is, it can't be like there's a short or a drastic arc somewhere. Otherwise we wouldn't have a good high voltage. So that's where things stand right now. I do have a spare one. So I've got that luxury. There's a bit of rewiring I'll have to do. I think there's 5 wires or so that run up inside here. So be a little bit of work to do, but I might as well do it, and then I can eliminate that possibility and search elsewhere. Here it is playing with a different 7JP4 and 25L6 tube, and it made absolutely no difference whatsoever. So next up, I will try installing this spare high voltage coil. I think first, though, I'll just try swapping out the mica cap because it's a little bit easier. And there are the 5 wires I was talking about. 2 for the filament to the 1B3 rectifier, and then the other 3 for various sections in the coil. I decided it was just too much of a pain to try swapping out the mica caps, so I just replaced the whole assembly. And I really hope this solves the problem. Otherwise, well, I don't know. I'm just going to keep my fingers crossed. Well, unfortunately, it did not fix the problem. However, the high voltage, I think, is a little bit higher potential now because the picture tube seems to be brighter and sharper, so at least I got that benefit out of the deal. But no, definitely didn't solve the static problem. So, well, I think the next stage to do is dig out my B&K 1077B television analyst, which is capable of generating video modulated to the IF frequencies that are suitable for these stages, and first inject a signal right at the video amp, and if that's clean, start working my way back as the interference It's got to be coming through here somewhere. Well, save that for another day. Because in order to do that, I'm going to have to clear out some room. Because right now, I just don't have any space for it. I'll have to get this B&K 415 out of here and stuff. So I'm going to put this in the back burner for right now, and I want to align this because I still have this equipment set out for doing an alignment for a set like this, and maybe finish off one or two other things. Like I really want to align my GE coaxial set over there, which uses the B&K 415 before I pack it away. So I'll get back to this set, but might be a little while. And if any of you have any suggestions, I would love to hear them.
Oh, what a nice meteorite. I'll wrap this up and surprise myself.
Bula, you're not a miner, you're captain of the Zula Patrol, remember?
Hmm.
Look out!